Hey everybody, welcome back. At this time, we will have an outstanding class about waves and what kind of waves do we have. Do you want to know more? Let's hit on ground running. So the first part that we gotta scrap or that we gotta understand is the concept wave by itself. Wave is the product of a vibration, right? In the case of a mechanical wave, is the product of vibration of the air around the thing that is vibrating. Then, for instance, if I have a rope, I can produce a wave, right? A wave. If I if I speak, when I'm speaking, my chords are vibrating. Then the first, if you wanna define the vibration, a wave, an overall view is product of a vibration of something, even the light. But it will be discussed later. So let's keep moving forward. Why? So the first concept is that the vibration is the main base of a wave, right? So we have kinds of waves, right? We have mechanical waves, electromagnetic waves, and electric waves, right? So that's the main point here. How many different waves do we have? So far, we are describing three kinds, right? Mechanical waves is related about the sounds, okay? And here we gotta understand this concept. Mechanic waves needs a middle to propagate. Oh my goodness, why all the waves do need a middle to propagate itself? Because it needs something to vibrate around, okay? If you're in the vacuum or in the emptiness, in the universe, there's nothing in the emptiness. There's nothing to vibrate, okay? So that's the main concept. I can know if I want to yell in the emptiness, in the spell, like it will sound. It will not sound, right? It will not sound. Why? Because in the emptiness, there's nothing to be played around, right? So that's the main concept. So now we have mechanic waves. Also, we have electromagnetic waves. There's, hey, this is a pretty strange name. Would you mind please breaking this down? Obviously, that's what I'm here for. So this concept is pretty easy to understand because electro, it means the real, it's electricity, right? Electrons. Magnetics means that I am doing something with the electrons, right? And you gotta recall this. If you put an electron in motion, it will create an electromagnetic field, right? That's a good point. Kudos for you, kudos for you. So electromagnetic waves, it can be transmitted in vacuum, emptiness. That's why we have two kinds of here so far, right? Two kinds of waves, mechanical waves that will need a middle to propagate itself. However, we have the another type of wave that is called electromagnetic. And let's recall electromagnetic don't need a middle. It could be transmitted in the vacuum. So Tisha, do you mean that here we have to know what is the electromagnetic waves? We have here light is an electromagnetic wave. Yes. Wi-Fi. Yes. Communications. Communication. Yes. Those are electromagnetic waves. Why, teacher? Because the light, or light itself, is photons vibrating, right? Photons vibrating. Wi-Fi and communication, the main point or the things that start this, I'm not meaning that is just this, but is the main point is the electricity, right? Because without electricity, you cannot make a modem working, right? So that's why I'm meaning this. That's electricity. Fisher, then you're saying that the photons vibrating is like electricity vibrating could be transformed or vibrating or flowing, right? It cannot be just vibrating, static vibration. No, it could be a dynamic vibration, right? Then it could have two kind of movement, vibration and advancing, right? So now that we have understand this, we have understood this, apologies, that we have understood this, that we have two kinds of waves so far, right? Let's 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 define graphically in our plot. This is a wave, right? And we need to know a lot of things about wave. A wave has frequency. That the frequency has its own and a specific equation. That is this. Frequency equal 1 divided time. Which time? The time that takes this wave to start over again, right? 2 seconds in this case, right? So 2 seconds. Okay, apologies. Here, this is a new wave, right? This is like a symmetric wave, right? This is the same wave than this. Then starting here, you're repeating another wave. So it does mean that this graphic or this plot will describe a wave. Fisher, but what is a wave? Something that has frequency, period of time, wavelength, amplitude. So, do you want to know more? Please keep watching. Here we have something called amplitude, right? This is called wavelength, amplitude, wavelength. Okay? This is where the graphic starts. This is where the graphic ends, right? However, here it starts over again, and here ends, and it's probably it will start this over again if my wave is going to be eternal, constant. So now we have to use this, obviously. Frequency equal 1 divided time. I'm describing this. I'm saying this wave is taking 0 seconds to start or to do it, okay, or to complete the cycle. It means that the time is 0.2. What's the frequency? 1 divided 0.2 equal 5 hertz. 5 hertz. What does it mean? Hertz. Never heard this before. Tisha, could you please explain in this? Obviously, that's what I'm here for. Hertz is the measurement of the frequency, right? It's how you're measuring the frequency. Then this wave will have a frequency, right? A frequency is equal 1 divided time. An important fact, a scientific fact here. This is the heatable range for humans, right? 20 hertz until 20,000 hertz. So if you wanna know what this is, what so this way, if I'm whispering, perhaps I'm into 20 hertz. But if I'm yelling, perhaps it's so closer than this, right? Then every single wave has a frequency, has certain features. Okay, let's keep moving forward, right? So let's do it. Now we have to check this. Teacher, you have mentioned something. Everything around is a wave. Is it right? Is it true? Obviously. Let's check it out. This is the sound, right? This is a note. This is the frequency. This is music, right? This is the color. This is the color range. The music range or the music scale. Okay. The range scale of tones. Perhaps. C, D, E. As you can see, it's a different amount of hertz, right? It has also something called mass. Then a wave could have, in this case, in the music, right? You could have mass and frequency. A wave as a color because it is product of a mechanical wave, right? Music, mechanical wave. That's why when you're composing something, right? Let me please do something amazing. Just grab this, okay? We are going to make an instrument right now, and we are going to understand what is the main difference, right? So the first part, let me please dry myself. Is this? We are saying that an instrument is a vibration of something. In this case, because we are producing a mechanical wave, we need air. If there's no air around, there's no oxygen, or there's no any gas around, there's nothing to vibrate, right? Then it could not sound. It would be like, right? So we are going to check what is the produce, what sound is produced if I make this. This is the amount of air, right? And this is the material. Oh my goodness! It's amazing. Different. Oh my goodness, it does work, obviously. Why? Because you are making something vibrating, right? Obviously, you can make something vibrating as well, such as this. This is much different, right? Because in this way, the things that is vibrating first is glass, right? All up to. The sound is produced by contact. It's produced by air flowing. But guess what? In the emptiness, there's no sound, such as, right? So we have already understood. To produce a sound, we need air, or we need a gases, right? Some gases. To do what? To vibrate. That's why a guitar, right? When you're touching a guitar, right? This is my guitar. This is no the most beautiful guitar that you're gonna see, but right. This is the guitar, right? Here around, here inside, I apologize. It has air, right? It is now solid. And it has chords. Let's try another one. I'm not good at playing the guitar, right? But I'll do my best. In this case, if the chords are vibrating, the chords are making the inside the guitar vibrating as well. And that's why you can hear and beautiful, astounding guitar sounds. Okay? Now, but when you have this another like, yes, like, no, this is another kind of instrument, like, oh, the one that is like, by friction, by contact, by applied force, friction. Sylvan, air flowing. Air flowing. I am making my lips vibrating with the air. My lips are vibrating. When I'm talking, my chords, my chords are vibrating as well. When I'm making this, applying force by contact, vibrating, friction. Okay, I hope that you have grasp, but it's a mechanical wave, right? When you do this, mechanical wave, when you connect your internet, electromagnetic wave, when you connect something to Bluetooth or by using Bluetooth, electromagnetic wave, when you are sending datagrams to the navel, electromagnetic waves, when you are using the microwaves, electromagnetic waves, when you are calling somebody, electromagnetic waves, when you are using ChatGPT, you are using electromagnetic waves. So the main point here is that there are a lot of electromagnetic waves around you, and all of them has different frequencies. That's why, let me please remove this when this lack of knowledge. When you're calling someone, your calling is working at certain frequency, 5 gigahertz. That's why you have 5G, the 5G technology. And the real meaning of this is that your wave is up to the 5 gigahertz. And teacher, when I'm having poor signal, what's the meaning of this? When you cannot call nobody, it means that you have not enough electromagnetic waves to reach another electromagnetic waves that we will bind them to the internet. Oh, teacher, every single thing around that contains, emits, or absorbs electromagnetic waves. Teacher, every single electromagnetic wave has a frequency as well. That's right. That's why the color is an electromagnetic wave, right? Because it's product of light diffraction, right? Because the light is the photon vibrating up to the light speed. Oh my goodness! And this is pretty much it, because this is the nanometers wave, right? This is the range. The red color has this range. Orange color has this wave. Okay? This is called a spectrum, the color spectrum. So teacher, thank you so much for being explaining this in this way. If you have got questions, please don't hesitate to ask them on the comments below. I will be more than glad to help you out. And please, if you have liked this video, give me my thumbs up, subscribe yourself to my channel, and guess what? Let's hit the ground running. If you have got questions, ask them on the comments below. It's Miller time.